while. Okay, they're closing the doors. So, first of all, Selena, can you hear us? Can you hear me?
Yeah, I can hear you.
Okay. Can you hear the audience? No, we've got to be louder. Got to be louder. Come on, audience. 1, 2, 3. All right, we can hear some. We can hear that. Is that correct?
Yes, I can hear that.
All right. So we're meant to both be here in real life.
Can you hear me? Hello?
Yeah. Yes, I can hear you. We can hear you. So we're meant to be both here in real life, but some last-minute changes meant, unfortunately, Selena couldn't make the trip up here to Sydney. Hence, we've just chucked her up on that big screen. And the benefit of that is actually her head is now as prominent as mine is on stage. So that's always a winner. Right, so I think we're good to go. Doors are closed. Let's cross our fingers that the internet holds out. So, Selena, what are we going to do here?
Oh, fantastic. I think I've just worked it out.
What? What have you worked out?
The ultimate architecture for all apps. I've worked out how to write all code going forward.
And how are you going to measure that? Hey, I've got an idea. Maybe we write a voting app together where everyone in this room will have the opportunity to share their view on the important debates in programming and computer architecture. It's going to be awesome.
Oh, that's a great idea. An app.
Oh, wow, this is delayed. Oh, so what I was thinking is that we'd build an app, which is a catalog of all the coding debates. Each of these usually have two sides, right? Like SQL versus NoSQL. And people can vote for their preference using their mobile. Results are collated on every topic. And finally, the results are displayed, probably up on that big screen. I guess it's probably going to be a big old monolith.
No. I'm pretty sure we're going to need microservices. The votes will go to an event stream fed to a vote processors service, which will feed to an aggregator service prior to being displayed by the results service. Oh, you know what? We're probably going to need a user registration service too.
Maybe. Well, we're both Ruby developers, so we could build it in Ruby. You devs out here in the audience, you're all Microsoft, right? So there is mRuby, which stands for Microsoft Ruby. You should go and check it out. Clearly, there is a Ruby developer who finds that funny. Yeah. Anyway, mRuby for you.
No. I think Rust is going to be way more appropriate for this project. Although, maybe we could start our prototype with Ruby. Anyway, let's get started. Hey, I just saw that last commit. What is that wall of weird characters?
Tabs.
Hang on a second. Are you suggesting we use tabs for indentation? Let's just recap what tabs and spaces are.
The concept of the tab originated as a way to make entering rows and columns of data easier on typewriters. Nowadays, tabs can be adjusted to various widths, typically ranging from the width of 1 character or to the span of 8 characters. Users or systems can decide how wide they want the tabs to be. In programming, tabs are also utilized to neatly structure code and enhance its readability.
The space is the white space character you get when you press the space bar on your keyboard. Funny that. We use white space to separate our words in English. And in programming, we also use the space to separate programming terms and tokens. Most programming languages also use a number of spaces to indent code. For Ruby, it's 2 spaces. For HTML, it's often 4 space characters. And all editors are equipped to enter the preferred number of space characters when the tab key is pressed on the keyboard. Round 1, developer versus developer smackdown, tabs versus spaces. Tell me more about tabs.
Right, let's talk tabs. Folks, tabs bring consistency by always having the same width for indentation. It's like the tab's main job is setting the right spacing for our code. And we all know how important single responsibility is. And guess what? Users can adjust the tab width to fit their liking, which means they can customize how the code looks. Just imagine coding on a small laptop. You may want to have 2 characters wide tab spaces to cram more on the screen. And those big screen office days, bump it up to 8 characters for comfy reading. Tabs keeping code cozy for all occasions.
Hold on a second. Let's get this straight. Spaces mean consistency. Tabs, on the other hand, can switch things up with different widths for each tab. Your first tab could be 2 characters, your next tab could be 4 characters, and the third 8 characters. Talk about a wild ride. Now, here's where spaces really shine. They're straightforward. One character is just that, one character, all nice and even. We want coding to be easy and inviting even for beginners. Think about it. When things are simple and familiar, they're easier to grasp. That's a big plus for those new to the field or changing careers. And why complicate life with invisible characters that come in all shapes and sizes, causing chaos for the unsuspecting? Let's keep it simple, shall we?
Spaces, my friend, you seem to have a thing for them. But hey, why not go all out? Why not use 6 or 8 spaces by default? I mean, tools can help, but trust me, you'll be wearing out that backspace key like there's no tomorrow. Maybe even breaking it in the process. Those keys have limits, you know. Tabs, on the other hand, bring consistency. That's a win for accessibility. Think about your team. Any visually impaired coders in the mix? Look at them. Look at me. I'm wearing glasses. Now I'll be able to read the lines, eh? Maybe you're all about welcoming them on board. Like if you want me on your team. For some people, a tab size of 1 character and a big font can be a game changer. Other times, those 8-character tabs do the trick. No argument can hold up against making accessibility to your fellow coders. And guess what? You can even switch things up on the go, like using the tab stop query parameter on GitHub. As demonstrated there, you can change the width of of the code in GitHub.
Keyboard durability, my friend. That's a new one. Are you really going through keys like it's a sport? And hey, are you even in the coding game these days? Are you still using tabs at all? Look, modern projects are all about formatters. So you write in your own style and the formatter does the rest, making everything look the same across the code. Imagine this. Tabs and spaces might look the same on the surface, but they're like secret agents, invisible but influential. Mixing them just adds confusion. Let's simplify things for our everyday coding. Spaces are your buddies for precise alignment, which makes your code easier on the eyes. Plus, they've got a popularity factor going for them. Except for some outliers like Go and C, most languages and their GitHub code prefer spaces. So there's that.
Just following the crowd isn't a good enough reason. Spaces are too strict. They won't let developers adjust for readability, and they hog memory. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision. Oh, and don't overlook size. Tabs use fewer characters, meaning smaller code, less bandwidth needed. End of story. If you're into tools like Make, which you totally should be, then tabs are the way to go. Plus, Go and a chunk of C code are tab fans. Even Ruby, your favorite language, has tabs in its core. So it's not just me, it's a code party.
All right, check it out. Spaces are easy peasy. They work smoothly across various languages, systems, and editors. We're already fans of using spaces to split up keywords and tokens in our code. And even if you're a tab lover, spaces are still in demand. Let's stick with just one sneaky character for all our needs. And hey, have you ever heard of YAML? Yep, it's all about spaces. Plus, here's a bonus. Developers who use spaces make more money than those who use tabs, as data scientist David Robinson found in the Stack Overflow 2017 developer survey. So, go with the space flow and maybe your wallet will thank you later.
Well, I think it's probably time to wrap this one up, but to do that, let's see what the audience thinks. So, over here we have a QR code, so scan the QR code, and I'm going to start our voting. You should now be able to start voting. So you can vote spaces, you can vote tabs, you can vote both. All right. Coming in strong. I think, yeah, come on, keep going that way. Yes, yes, a few more that way. Come on, we can do it. All right, let's, big reveal. How do I do the reveal? And the reveal is, well, it looks, oh, God. Oh, where's my, oh, there we go. Whoa! So, all right, tabs. Tabs didn't take this one out. All right, let's see what's next. Let's see what's next. You guys don't know what you're doing. All right, I should have really bought a mouse. Selena, are we going to pair or solo on this one?
What do you mean pair or solo? We'll just split up the work in cards and work on it.
Well, sure, but we could still choose to pair. Pair programming is a development practice where two developers work together on the same code at the same time, usually with one developer writing the code and the other reviewing in real time.
Sounds expensive. Working solo is what most would consider normal, where a developer works alone, all by themselves. It's not like they need anyone to hold their hand. Once the code is in a finished state, it's peer reviewed by other developers on the team. We would get twice as much work done soloing compared to this pairing idea. Ridiculous.
Round 2, developer versus developer, Smackdown, pairing versus soloing. Selena, you could afford to do more pairing. Maybe then other developers would understand what your code even does. Pairing has a bunch of perks. It boosts code quality because two sets of eyes are on it, catching errors and bugs that one person might miss. According to Alistair Cockburn's 2000 paper, pair programming only takes 15% more time to solve a problem, but on the plus side, better design, fewer bugs, less risk, and it's more fun. That's statistically proven. You do enjoy pairing with me, don't you, Selena? Teaming up means more collaboration, which makes for a better work vibe and lifts morale. We share our skills and learn from each other. Plus, fresh pairs can improve best practices and share ideas while working together or pair swapping.
Wait a second. Think about all those movies showing hackers as lone wolves in dark rooms, rocking headphones and hoodies and totally zoned in, developing software. It's all about getting in the zone. Flying solo lets you concentrate. Music, quiet, no distractions from messaging, just you and the task. No boredom, no one pulling the project elsewhere. This means more output since you set your pace without chit-chat. But hang on, the big debate around pair programming is whether the gains are worth it. Is it a win in the end to have two devs on a task that could easily be handled by a solo programmer?
The flow zone. As Uncle Bob would say, you'll type way more, you'll feel awesome, but the code will probably stink. Bob's tip, if you're in the zone, take a break. Michael says, skip the blind code spew zone and team up instead. Pair programming rocks for readable code. It stops knowledge from hiding in one person's head. Both pairs own the code and know how it ticks from the beginning. Pairing boosts talk time. That's right, better communications. Constant negotiation makes devs see all sides of the code. Double the ideas. Both folks stay in the loop. Tailoring the chats to the pairs for best results. Lots of chatting means smoother work and less fuss coordinating changes later on. Pairing speeds up learning too. Imagine your project hits the stars, grows, and new folks want to join. They catch on faster with code and business smarts if they pair. Juniors love this too. Pairing with pros, seeing different ways to fix stuff. It's amazing.
Gotcha. Pairing is awesome for learning and communication. But what about personality clashes? You know, some folks just don't jive with high energy pairing. Not everyone likes talking aloud or sitting shoulder to shoulder all day. And skilled coders might prefer their own coding turf. You know, flying solo has perks. It gives devs flexibility to work when and how they want. That's great for independent workers who like their creative freedom. They dive deep into stuff that sparks their interest, exploring new ways to tackle things. It's smoother to work at your own pace, developing your own style and testing new ideas. Oh, and let's talk about money again. Do you know there's a cost of living crisis going on at the moment? Solo can be cheaper for the company than pairing up. Usually, you only need one dev for the job. Simple tasks need fewer hands. No back and forth, decisions are quicker, and you don't have to keep a teammate up to date on every change, so you can tackle bigger parts all at once.
Big steps on your own? Whew, that's not my style. I prefer small, agile moves. Always build, measure, and learn. Speaking of small, check out feedback cycles. Sprints give you a weekly feedback cycle, tests maybe every 5 minutes, but pairing, it's like instant feedback, seconds fast. Faster feedback means less waste and quicker feature development. You make better choices, avoid wrong turns, and prevent over-engineering. Sometimes solo developers even forget what the problem was that they were trying to solve in the first place. Working alone can lead to iffy code quality, no extra eyes, less collaboration. That's like a wall between you and the team. When devs own the code together, they step up and solve issues. The added accountability of having a pair sit with you means you're less likely to have code which doesn't adhere to team standards, have developers who are not considering multiple options, and developers who give up on improving their solutions, or code that just isn't adequately tested.
Your take on accountability sounds to me like micromanagement. I think some of the audience who are voting already are seeing that as well. Pairing can mess with the flow, forcing programming sessions even when you're not feeling it. Some folks work better when inspiration hits in their own rhythm. And guess what? Pair programming isn't meant for always. Going solo has its perks. No clashes, no drama, just managing your own show. You need to master problem solving and learn the ropes yourself. Being on your own helps you gain confidence, fight imposter syndrome, and prove you're fantastic at creating top-notch software. So there's real value in flying solo too.
Let's see what the audience thinks. So pull out your phones, same QR code, probably the same page. I think I can move Selena down as you're voting. Pairing versus soloing. Still waiting on a few more people to actually click. Oh, okay, maybe they're going that way. Hey, come on, pairing. You want to pair with me? All right, I think it's time for the big reveal. And we have, whoa, big win there for soloing, 36-21. Oh, all right, you get that one. So we didn't see your little winning dance there. Go again. It's all right. We'll see who's got the winning dance at the end. All right, let's go. So I guess we should really make a start on this thing. What editor should we use?
What kind of question is that? We're obviously going to use Vim.
How is that obvious?
Well, it's not like we're going to use Emacs.
Whoa. So now you have an issue with Emacs as well?
Yeah, I have an issue with Emacs. The issue is that it was only an issue back in the 70s. Why is it even still a thing these days?
Emacs, which is a really flexible text editor, actually goes way back to the 1970s, as you mentioned, just like VI does. Emacs was initially developed by Richard Stallman as a set of editing macros for the Tico editor. Over time, it evolved into a full-fledged extensible editor written in Lisp. It's Emacs Lisp that allows for powerful customizations and has an extensive set of packages.
VI, short for Visual Editor, has been extended to be Vim, or short for VI Improved. Vim is a super fast and productive editor and that's gained a large and dedicated user community, becoming one of the most influential and widely used text editors across various platforms and programming languages. Vim motions are a fundamental game changer in editing, so much so that even Emacs uses the Vim bindings in their evil mode. Round 3, developer versus developer Smackdown, Emacs versus Vim. Not sure you would even know how to exit a Vim session, so why don't you tell us a bit more about Emacs?
Come on, Selena. Nobody would have guessed capital ZZ. Whew. The fact that the most read Stack Overflow page is not about how to exit Emacs means Emacs should win by default. Speaking of by default, most systems, like the Macs we all have Emacs turned on by default. If you're using .NET, Emacs on by default. Just type set -O and you'll see Emacs is on by default. That's why in the terminal, hitting Control-A takes you to the start of the line and Control-E takes you to the end of the line. It works in Google Slides, Word docs, VS Code, and all the other tools as well. And guess what? All those Emacs shortcuts like Control-R to do a reverse search work everywhere. Your terminal, your text editor, your IDE, some browsers, the list goes on and on. Emacs isn't just for editing text though. It's like a hub of different tools like code editing, making documents, managing emails, and more. With its bunch of modes and packages, Emacs can become whatever you need. Plus, it's known for being super customizable. You can build complex stuff, make your own functions, and create your own features. Emacs is like the superhero of editing.
Why does Control-A take you to the start of the line? Is it because A is the first letter of the alphabet? And then why isn't Control-Z the end of the line? Oh, that's because in most terminal apps, you would put the app in the background. That would put the app in the background. And moving around is like a workout. Control-P for the line above, In Vim, everything's on the home row, right under your hand. KJ for up and down, HL for left and right. That's efficiency right there. Vim even stands for VI improved, and lots of commands are shortened, like U for upper page, G for down page. Efficient all the way. And here's the magic. These are one-key commands. No crazy Control, Alt, or Meta keys. Vim uses modes like an insert mode for typing and a command mode for commands. There are even visual modes for jumping around and highlighting. And if there's one reason everyone should use Vim, it's Vim Motions. This mode system is why Vim is so powerful. With simple key presses, just like Emacs, you can customize Vim, especially with cool versions like NeoVim and Lua. And the best part, it's super fast.
You're pointing out how Vim's commands seem logical. But everyone agrees that Vim's learning curve is steep. Just look at the graph. It's all or nothing. And then there's Emacs with its cool little spiral. You know why? Because Emacs is not just an editor. It's like a whole operating system. It has this programming language called eLisp, which is like magic. eLisp lets you customize and expand Emacs in mind-blowing ways. Yeah, Emacs might be a bit slower. It might take 2 seconds to open up on an older system. But here's the thing. Why would you even close it? You can run a shell inside Emacs, like a software inception. Feeling dizzy yet? With these shells in Emacs, you can practically live in it 24/7, listening to music, jotting down notes, and even playing games. It's all in one hub.
Thanks for helping me prove my point. We're not here to make to-do lists, listen to music, or play games. We're here to write code and zip around with Vim Motion key bindings. Whether you're using less to check out a Git log or any console with Unix readline, like a database console, you can zoom around with Vim Motions. Even new tools like K9s, which handle Kubernetes clusters and Vim-style shortcuts, master those Vim Motions keys, and you'll reap the rewards in loads of places. And guess what? Even your beloved Emacs has an evil mode that uses Vim bindings. Because let's face it, Vim shortcuts are just a better way to edit files. Vim strikes the perfect balance. It's fast, it's powerful, and adaptable without being a nuisance. To code effectively, there's a basic level of skill you need. And you know what? That skill should include using Vim for editing.
I said it before, and I'll say it again. Vim can be tough for beginners. The setup and keyboard commands can feel overwhelming for newbies. The learning curve can be steep, demanding time and effort to get good at it. Remember, coding isn't just about writing code. Some of the best code you and I have seen written was by coders who could barely type and don't have an opinion on an editor at all. Coding is a big, immersive adventure. You need all the things, the code itself, library explanations, the grand plan of the project, guides on how stuff works, version control magic, and more. And this is where Emacs shines. It's more than an editor. It's the one-stop shop for all of these things. That's why Emacs wins in the productivity race. It's simpler to start with, and you can level up its power using tons of community plugins or by making your own.
Sounds like a jack of all trades, master of none. Imagine taking one thing and making it super awesome. So good, you don't even notice it. This is the key part of the connection between your brain and the computer through your fingers, the keyboard. Using Dvorak, of course, right into the editor. It's not a tool to fiddle with and customize a lot. Instead, it's like a crucial link between your programmer brain and the computer, almost like a nervous system. And that's what Vim nails.
Vim is a part of your nervous system? Right. There really isn't much of a difference between them at all. They're equally terrible, and I don't even know why this is considered a debate topic, but it's up to you, the audience, to decide. Vim or Emacs, pick your poison.
I can't believe you just said that to a room full of developers. Of course Vim is going to be the winner.
All right, everyone's voting. We've got the right votes, Emacs versus Vim. Emacs, like you're all on your Windows machines, trying Control A, Control E, going, oh yeah, this is working. And the winner is, clearly it's going to be me. Vim. All right. That's 2 for you or something like that. Who's counting? Come on. All right. Well, now that we know that, let's go.
I think I'm getting 2 votes because I'm on the screen and not in person.
It's because you're bigger. You've got more presence. That's why they're voting for you.
I don't think so. I think it's the arguments. I think, though, we've discussed some good ideas today, and it's probably enough that I can get started on a few things.
Get started, but Selena, you're in Melbourne remote. I mean, sure, we may not pair all the time, but we should at least be in the same place when we're working on this.
Michael, are you serious? Did you forget about what happened in 2020? Remote working is the way now.
Well, it was for a while, but a lot of places have conceded and gone back to the office. Just look at Amazon last year. Anyone who didn't want to move and be within commute distance was voluntarily dismissed. Oh, and Zoom, they've gone back to the office. Isn't their whole product a remote sharing tool? Anyway, maybe you've forgotten what real life was like. Let me remind you. Being together in real life, IRL, when working, also known as working in a physical and co-located workspace, offers a number of benefits that contribute to effective communication. That's why we're all here, right? Collaboration and overall team dynamics.
Remote working is a work arrangement where employees perform their duties from a location outside the traditional office, often working from home or other remote locations, using internet-based technologies to stay connected and productive.
Round 4, developer versus developer, Smackdown, real life versus remote. Let's take a look at why working IRL has been so popular for so long. Face-to-face chats are gold. You get clear, instant communication. No, can you hear me? Nonsense. Plus, those eyebrow raises, those gestures give extra meaning to words. Avoiding mix-ups, being in the same room is like a creativity booster. You can chat, brainstorm, solve stuff in the moment, cooking up cool solutions. And guess what? It tightens the team bond. Trust grows. Everyone gets each other better. And that team spirit shines. Decisions, bam, they happen faster. Quick talks mean quick fixes and agile moves. We've been at this as humans for ages and for good reason.
Embracing remote work is like adding extra toppings, and you know how I love extra toppings. People say they're super productive at home, less noise, more focus. And you know what? Companies love it too. They care about what you deliver, not when you clock in. And guess what? Your life's a better mix. Work, family, beach, whatever you like. No more stressing over traffic jams either. Surely, after traveling all the way to Sydney, you'd know what a stressor commuting can be. Remote work says goodbye to all of that.
Actually, by leaving Melbourne and coming all the way here, I got rid of the family and the dogs and all that. Stress. There's no stress like being completely isolated in a remote environment, having no idea if anyone else is even online, or if they're just annoyed at you, or they're trying to avoid you, or if they've frozen. I'm like, Selena, have you frozen? Everyone's in, exactly, right? Yeah, there's no stress like a little more anxiety. Thanks, but no thanks. What I'd prefer is to work in person where you get a little bit more informal knowledge sharing, where you can really build up a collective learning environment. Working in person means we take our tasks more seriously. Remember how we put this talk together, Selena? Sitting side by side got us through. And hey, being together boosts engagement and job satisfaction. A more positive work environment can have a significant impact on morale and job fulfillment.
Looking for job happiness? Stuck in a cubicle won't do it. I will take my beach view and time with my family any day. Yeah, that's right. Flexibility is what makes me feel satisfied. Remote work offers flexibility, giving people more control over their work schedules, enabling them to balance professional and personal responsibilities effectively. And here's a bonus. Remote work means a bigger talent pool. That's right. This talent all the way over here in Melbourne has been made available at your conference all the way over there in Sydney. You're welcome. And by the way, thanks for being so inclusive. Did you know remote work can be more inclusive for individuals with disabilities or those who face mobility challenges, providing them with greater opportunities to participate in the workplace? Remote work for the win.
I think you'll find, Selena, that all the way over here in Sydney with my new friends who I've made through real life connections, We're going to be very happy at the end of this when we switch you off. Oh, and I guess that's actually another benefit for remote. Over here in Sydney, we had karaoke last night, and that is only fun if it's done in person. Back to business though. Real-time talks and teamwork make solving problems a breeze. Better results and more team power and more team power. And then when our app really takes off and we need to hire new talent, in-person onboarding and training sessions can be more engaging and effective. Look at all of us here in a conference in person, allowing new employees to build relationships, ask questions, and receive immediate feedback.
I'm still not sold on the idea that in-person work has unique benefits. Remote work has a bunch of cool extras too, and I haven't even mentioned them all. We're talking about the environment. Remote work can cut carbon emissions by reducing commuting and office energy use. Plus, diversity in the workforce. Companies that embrace remote work attract a wider range of candidates who need or want flexible options. And health perks. Remote work can mean less exposure to germs, keeping folks healthier and stopping the spread of sickness, especially when you're not touching my keyboard.
I'll bring my own keyboard, but you've made your point. Let's see what the astute developers of Sydney think. Scan the code, get your votes in, you know the drill. We're going to move Selena down. We are doing real life versus remote. Has somebody done a accessibility analysis on my website, on our website? No? Okay. And, all right. Well, next time we'll just do a remote conference then, like if that's what you want. Yeah, but you know, I'm not that surprised. It was worth a shot.
I guess the singing wasn't that good at karaoke, Michael.
That's right. Yeah, karaoke was good. Let's go.
All right, well, back to the project. I'm thinking the stats collector will need to be very performant, and we may want to split that out into a separate service.
Whoa, hold on. A separate service already?
Yeah, I mean, this has to be able to scale from the beginning, and you don't want the performance of the stats collector impacting our presentation of the results. You know, if one of the clients goes rogue.
I think we might be getting a little bit ahead of ourselves. Maybe we should recap what it means to have one app versus many services. Meet the monolith. It's like having one superstar app that's the go-to for everything. Your fancy interface, the smarts behind the scenes, and how you get your data. This setup's been around forever, and it's all about having one powerhouse that does it all. Super easy, super reliable, and it works like a charm. Picture this, one app, one database, handling everything from the cool stuff that you see to the behind-the-scenes magic, like taking care of users, administration, and showing off the facts and figures.
Microservices, imagine a group of buddies all working together like one smooth app from your viewpoint. This style's all about teamwork. You've just emphasized teamwork. So like a crew of many heroes doing each doing their special thing, all chatting through APIs. It's like having a bunch of separate apps, each with its own storage, joining forces via APIs. Or not APIs. Each app shines at one thing, and when they team up, it's like having the whole show in one go. Flexibility, scalability, and speedy development are the perks here. Round 5, developer versus developer Smackdown, Monolith versus Microservices. All right. Tell us all why monoliths are so great then.
All right, let's kick off. Monoliths are the easy road. They're simpler to handle, develop, and manage in one tidy code bundle. They're like reliable workhorses, perfect for smaller projects when you're after straightforward reliability. On the flip side, we have microservices. They're like chatty teammates, teaming up for greatness, but bringing out extra complexity. Building and managing them, it's like conducting a lively orchestra. Now, for our app, the voting app, what we're aiming for is to get the core business logic right. We just want to present a topic, have users vote, tally those votes, and then reveal them. If we dive into full microservices from the start, we'll end up spending more time getting things up and making them compatible than writing the app. And security? That's a whole other layer of concern. Imagine accidentally allowing a user to publish something directly to our stats display. Yikes.
Sure thing. We need to set up each service and figure out how they are interconnected, which sounds like work, but as our project grows, and it inevitably will, so does the monolith's complexity. Imagine the app is like a puzzle or a game, and with a monolith, it only gets bigger and more complex. Now picture this. Getting stats and showing them off are like two different games. Mixing them up could turn our app into a jumble. That's the monolith. But if the games are two separate services, you can play each game separately, getting stats or displaying stats, and they won't mess with each other. Plus, we can make them work harder by adding more teammates to a particular service. You and I are the VIPs for viewing stats, so one server is plenty. But lots of folks voting, we'll need a bunch of collectors to handle that crowd. Horizontally scaling individual services is how microservices can help us scale.
Yeah, I get you. People can write messy code in any setup, even in microservices. If they're not careful, making them into these tangled distributed messes. And fixing that mess in microservices, way harder than in a monolith. Monoliths have a clear view of tangled code if you get there and need less gear to sort it out. But let's get real here. Why do we need 3 services, 3 databases, just to find out if tabs are better than spaces? Now think about this. If we want to make vote changes, like letting users take back a vote, for example, it's like changing a bunch of gears. We'd have to tweak the front end, update voting, tweak aggregation, and update stats, orchestrating and deploying each microservice and with compatibility for any other microservice already deployed. That's complicated. With a monolith, it's like fixing a puzzle all at once. Easy peasy, quick changes, all in one place, one update, and one deployment. It's faster, simpler, snappier. We're good to go, I think.
Speedy, but with a catch. Imagine if the main hub goes down. Poof, the whole system's toast. And let's say a wild user goes nuts on our stats. Too many connections? Boom, we're effectively DDoSed and the stats don't show up. Nobody wants a single weak link. But check this out, with our resilient microservices, if one part stumbles, like our stats collector taking a nap, no big deal. The other stats will party on. One service fumbles, all the others keep grooving.
Monoliths can still be scaled, just like we've done it for years. Toss in an API gateway and some caching if needed. Now, let's talk about those multiple moving pieces. They can slow things down since they chat over the network, which means there's a cumulative latency overhead. Things take a little longer each time you add another microservice. Each piece talks to the next, building up time. And we want those stats lightning fast, right? Just like your snappy responses in this debate. Testing microservices, bit trickier, more pieces, more chats. But with monoliths, one big code family, easier to test. For small teams with not much to spare, a monolith's your champ. Fewer pieces, less fuss.
Okay, I see where you're coming from. But think about this. With a monolith, you're kind of tied down in your tech choices. You've got to keep everything compatible with that one big code family and watch out for those dependency clashes. If different parts want different versions of the same friend, chaos alert. Now, microservices, they're flexible, like tech chameleons. Each can strut its stuff in a different tech or language, and updates, they're a breeze. You can tweak and easily deploy them one by one, which makes changes a piece of cake. Plus, they're simpler to understand. Think of it like this. You could rebuild each microservice in about 2 weeks. So understanding the whole code, it's totally doable. Unlike a monolith, which can grow so big that even the smartest brains can't grasp it all.
All right, well, it's over to you. What do you think, monolith or microservices? Scan the QR code. Votes are coming in hot. That's it. More of those blue votes.
I think we should vote as if we all work for really big products.
Just remember, it's 2 developers creating this voting app. And the winner... Woo! Oh, come on! Yeah! Yeah, I'll take that. Yeah.
Oh, no, one more. Oh, so close.
Yeah, so close. All right. So it looks like we need users to create votes, register, and also we need to fetch the stats. We should be good with a users, votes, and stats endpoint, right?
Endpoints? What do you mean? We can just fetch it via the query on the GraphQL endpoint.
GraphQL, we don't really have a huge graph of data here. Surely having a couple of dedicated endpoints will be enough. I mean, I'm not going all Hateos on you just yet. And you wanted this to be small and performant. I say we just go with REST. But maybe we could compare the two and see if an obvious choice jumps out. REST, R-E-S-T, stands for Representational State Transfer. Often REST is only implemented to perform simple CRUD, create, read, and update, delete functions, and uses the common HTTP verbs get, put, post, and delete.
GraphQL is a data query and manipulation language for APIs developed by Facebook in 2012 and open source in 2015. As opposed to exposing many endpoints, GraphQL exposes a single endpoint and responds with precisely the data a client asked for. A GraphQL server can also fetch data from separate sources and present the data in a unified graph.
Round 6, developer versus developer, Smackdown, REST versus GraphQL. REST is older, so how about I start? Back in the days before 2000, when I think you were still in diapers, there was no set way to design or use APIs. APIs use protocols like SOAP and were really complicated to make, understand, maintain, and fix when something went wrong. Then in 2000, a bunch of smart folks led by Roy Fielding came up with the REST architecture, and it totally changed the API game. REST is all about letting two services anywhere in the world talk and share data as long as they're connected to the internet, especially when it comes to client-server apps. It's made for big internet use and allows standards like HTTP, URI, JSON, and XML. The cool part is that REST makes the client and server work separately and uses text to send information. Plus, it's easy for developers to use REST services. Remember those early 2000s when we could finally see JSON coming from servers and quickly mash up a couple of APIs? That was thanks to REST making data fly around everywhere.
Us developers realized that REST was a step up from the chaos before, but it's not that great for a couple of reasons. First, there's no official guide on how to do a REST API. Yeah, we have HTTP verbs like post and put and response codes like 200 and 403. But if someone asks, what code should I use if a user can't access something? Is it 404 not found or 403 unauthorized? The backend makes a guess. Then the front end makes guesses on the backend's guess. And this guessing leads to bugs. But look at GraphQL. It's got a formal specification at spec.graphql.org. This is where the explanation by the GraphQL language, this is where they explain the GraphQL language types, how to check responses, everything. It makes it way easier for new developers to hop into a GraphQL project and know what's available in the API, how to use it, and what to expect back. REST leads to endless debates about whether something should be a put or a patch. Have you ever seen someone using a phone and thinking about whether something should be a put or a patch? No, sorry. Have you ever seen someone using a phone app and thinking, I sent a message to my friend. Was that a put or a patch? Well, tip for you, they don't care. And with GraphQL, all those arguments go away. Not only that, but you also have a contractual agreement on what is returned and what type it is. It's in the query you send to the server. It will pass exactly the fields that you want returned.
Selena, users of an app aren't thinking, did that button do a type check or on what's coming back? They care if they can get a snappy response no matter how many users are using the app at the same time. And guess what? REST can scale just like the rest of the internet. By following some rules like being stateless and built-in scalability, REST brings performance, scalability, simplicity, and reliability. It also makes things modifiable, portable, and maintainable thanks to its uniform way of dealing with resources. When you ask to create a vote, you might get a status 500 if the server's down, or a 422 if the data's wrong, or a 403 if you're not allowed. And the network along the way knows exactly what's going on and what to do. When you get current stats, a status of 200 success and special headers that let the response be cached, saving server work and network traffic. But in GraphQL, everything is a response 200 success. 200, you're unauthorized to access this. 200, your query is invalid. 200, this is the millionth time I have responded with exactly the same data, but I'm not allowed to cache it because GraphQL. Like the karaoke from last night, in the words of the NDC renowned line breakers, your API's a wall of shame. You give REST a great name. REST builds on the scaling of the internet.
Every choice has its ups and downs. You know, with GraphQL, you can make your app more efficient. All about efficiency, aren't you? Each user can ask for exactly the data that they need, which stops wasting time and data. Unlike in REST, where you might ask for one thing and get led to another, GraphQL has the flexibility to precisely choose the info you want all in one go. Unlike REST, where you have to plan out each data request, GraphQL lets you set it up and give you control to the app. Also, GraphQL has a strongly typed schema, which can help with catching errors and reducing miscommunications between teams. It is also good with complex queries that would be difficult or impossible with REST. In all this flexibility and consistency leads to greater developer happiness and a more decoupled design between the back-end data and the front end.
But hold on, Selena. Our app is just about voting, gathering data, and showing it. So what's the super complicated stuff that you're thinking of? Like, what types of data do you need? And what exactly are these super fancy queries you're dreaming up for in our app? Let's just keep it simple, shall we? All we need is a get a topic, to put a vote, and to get the stats. It's like a smooth flow, right? Oh, and if we were to change things rather than GraphQL, we could use WebSockets or HTMX. Who even needs an API? There's more than one way to write an app. I say you vote for me, you vote blue, vote REST, vote for the singing, and just be done with it.
You know what? Building apps in different ways might seem tempting, but it's not always the smartest move. Consistency pays off big time, and that's why I'm all for GraphQL. Trust me, picking the red side is choosing the right path. Go for the right path! And that's 100% true fact. Plus, this voting app will be a breeze with a single GraphQL interface. We only need to set it up once, and then clients can ask whatever they need. The back end and the front end will be clearly separate. One of us can focus on storing the data, while the other works on how it's used up front. It's like a winner that keeps both sides happy. We need more red votes.
All right, well, call me a full stack kind of girl, but what do you all think? REST or GraphQL? Scan the QR code and vote.
Are you a full stack kind of girl?
Oh yeah. Thank you. Woo! Yeah. Was there any GraphQL talks here? No. All right. We're almost there, I think. We should have this app written in no time.
I'm disappointed that I didn't turn up then. With votes like that. Okay, all right. Do you know what? I've got an idea for a new feature we can add. It's on a branch and...
What? A branch? Why is it on a branch?
Because we are developers and we work on branches. What do you mean, why is it on a branch?
Well, there's only two of us, and I thought we'd just work on trunk, since it's way more efficient. And that's just the way people do it these days. Like everyone here probably just pushes straight to trunk.
Do they though? How do you get your code reviewed? Which people exactly don't use branches? How would you even get your code written in the first place if it's not on a branch?
With trunk-based development, we're all about those bite-sized code pieces, sending them up to trunk non-stop. Yep, that's why it's called continuous integration. It's continuous, not batched up in branches. So if you want to do CI, you need to push straight. And the payoff slashes the time between starting a change and getting it deployed. We're minimizing branch time, aiming for more teamwork, constant integration, and early high fives.
Feature branching is a popular move. We're talking separate branches for specific jobs. Enhancements, new features, bug fixes, they all get their own branch to play in and not interfere with other work. Here's the deal. The main branch, think develop or integration, is our stable base. When a feature is done, verified, and ready for release, then it gets merged. No half-finished work being deployed. Round 7, developer versus developer, Smackdown, trunk versus branches. Oh, you're so losing this one, Michael.
Really? I've got 3 words for you. Faster feedback loop. Boom! Changes hit the trunk often, which means speeded deployments and quick feedback for your devs. Catching issues early, less debugging time, and say goodbye to huge code conflicts, right? Now, for this project, pushing to trunk is the only way to go. You code, you push. That's it. Simple as that. Refactor a test, a new API class, bam, it's there on the next pull. Front-end updates, let's get them soak testing it right away. Even if it's not all done, we're deploying and watching changes hit production bit by bit. That's the only way to be sure that our stuff is rock solid.
Code conflicts. Do you know what? I've been tackling them for decades, no sweat. But for code to go to production, you need pull requests. Actually, it hasn't been decades. I'm not that old. Don't believe it. Almost a decade. What was I saying? Yeah, for code to go to production, you need pull requests, a solid PR process to guarantee quality. More importantly, how do you write code with everything interfering with everything? Picture branches like a highway with many parallel lanes. Trucks and tourists, like big features, take their lane, and bug fixes or updates take the fast overtaking lane. Different teams or features or cards are like cars in different lanes, all working towards the same destination, but not interfering with each other, like renting a car or jumping on a motorbike in the fast lane. This lets you experiment with cool stuff too. Any type of branch isn't vibing, you can just ditch it. No fuss and no harm to the main branch. For our app, we will likely have a very clear flow from Kanban card to branch, to pull request, to develop branch, to production deploy. Simple. No messy conflicts dance between different tasks. Chaos is not our style.
Chaos? Oh yeah. Web development's wild. Forces pull projects in all directions. Product, architecture, legal, marketing, Agile's like a chaos hugger. We're not building grand cathedrals here. Nope, we're crafting bazaars that are reactive to consumer needs, self-organizing, can grow and flourish quickly like nature. Agile's about the journey, and we never really reach the destination. So we need to embrace a smooth process for continual development and improvement of our software. TBD, trunk-based development, will help improve collaboration. As soon as something is committed, the whole team will have access to it, use it, they can extend it, they can refactor it, they can delete it, they can interact with it in the browser or wherever. This is only available to us if we push directly to trunk. We'll also catch potential conflicts and interdependencies early on and not at the end of a feature. The faster feedback leads to overall enhanced code quality as issues and bugs are identified and resolved sooner whilst you're developing the code, reducing the risk of technical debt accumulating over time. The collective ownership of the trunk code base promotes a shared responsibility for the code quality. You're all about CI, continuous integration, and quality, right, Selena?
Code quality? Absolutely. But shared responsibility? No, it doesn't fly. Feature branching, super useful for new stuff or tweaks. Each branch is like a private room. Your changes don't mess with others. Safe spot to play around, try new things. Very 2024. Branches means easy sharing, reviews, and teamwork. More teamwork means higher code quality, standards met, and catching issues early. Also, not all changes are features. What if we have a bug and we need a hotfix to push out? We don't want to accidentally push an untested feature. We are safe in the knowledge that we can push out to production branch with such a hotfix.
Untested features? Branches might lead to skipping the good stuff. Testing and feature toggles, you should have them in from the beginning. I thought higher of you, Selena. Maybe that's why failure driven sent me to Sydney and left you back home in Melbourne. Trunk-based development leads to less work in progress, less WIP, which in turn means faster time to market, accelerating the delivery of a new feature, of bug fixes, of enhancement. It allows teams to release software more frequently, respond faster to customer needs, and quickly iterate. Maintenance and troubleshooting is much easier because changes are made in smaller increments and integrated regularly. It's simpler to track down the source of any new issues since code changes simplify the debugging process. And finally, trunk-based development aligns better with continuous delivery practices, which emphasizes the frequent and automated deployment of software. By maintaining a releasable state in the trunk at all times, teams can more easily achieve continuous integration, automated testing, and efficient deployment pipelines.
But what if things go haywire on the main branch? Or what if we've got half-baked features that shouldn't go out with other stuff? Sure, feature flips could work, but there's room for slip-ups, right? That's where feature branches shine. Changes stay cozy in their own safe space. Not to mention that branches and PRs is how open source works. So it's the basic semantic versioning that has a good way of dealing with bugs separately from any features being developed. Also, branches are the only option in deployed software like hardware, TVs, cars, phones. That's where there is a gated process to release the code anyway. And it often relies on the user to perform the install of a valid release and not some half-assed in-progress trunk-based mumbo-jumbo. Come on, branches for the win!
All right. Wowee, we went deep into that topic, trunk or branches. Have you all voted? Still scan the QR code. We'll move Selena across.
So even.
We'll move her across. Yeah, let's go. Whoa, it's getting close. Come on, trunk-based development. You want those changes early? All right, I'll give it to you. Let's continue that. So, it looks like you certainly did win that last one. Let's move this over here. Let's do the full reveal, the stats reveal. Is that the right one? I'll toggle the scorecard. Oh, there we go. All right. And then I have to refresh
you have it.
And then we go, NDC Sydney in there. And it's 24 to 27. How does that work? How does that bottom one work? Oh, that's the last one. Okay, so it's 177 to 213, right? So I meant to hide the stats. Hide. No. Yeah, there we go. Oh, okay, cool. Anyway, well, look, as a complimentary prize, you got to win the results today, Selena. But certainly, I got to win meeting all these great people. So thank you all for joining us. We have been the brother-sister duo of Selena Small from Melbourne, Michael Milewski, also from Melbourne, but here in real life in Sydney with you. Come and chat with me if you have any thoughts or ideas on this. And I think we should probably hang up on Selena very shortly. But before we do, maybe we do a quick selfie. How do we do a selfie? Oh, you're down there as well, right? We could do that. Yeah. And then we can do... Oh, somebody's taking a photo of Selena. Oh, yeah, there we go. Yeah, and then we got the results in there. Cool. All right, and maybe a big applause that Melbourne can hear it.
Michael, you forgot to do the last slide.
Okay, next slide. Oh, yeah. That would have been great. That's it. So Selena Small, Michael Milewski, brother-sister duo. Follow us at Failure Driven. Sometimes you can see what we do there. We do a lot of conference talks, maybe a workshop coming soon as well. Feel free to follow us and tweet us, X us, whatever that is.
We're actually the sister-brother duo, by the way.
Sister-brother duo, yes, there you go. Cool, all right, well, thank you. You've been an awesome crowd. You've voted blue and red here, but vote green when you go out. Thank you again.